Welcome to August 29th LeetCode Challenge. Patching Array. Given a sorted integer array nums and the integer n, add / patch elements to the array such that any number in the range of 1 to n inclusive can be formed by the sum of some element in the array. Return the minimum number of patches required. So example 1, we have nums array of 1 to 3 inclusive, right? And we have n equals 6. So what we want is basically we want to know the minimum number of patches required such that we can make an array that has a property where we can take the sum of some amount element in the array to equal n. So for example, we have combinations of, for instance, we take 3 and 1 and 3. So the possible combinations from this numbers array is we take 1 alone, we take 3 alone, or we could take both 1 and 3, which forms the possible sums of 1, 3, and 4 respectively, right? Sum of 1 is 1, sum of 3 is 3, sum of 1 and 3 is 4. But that's not enough to equal 6 yet. So next thing we want to do is, we have this so far. So now we would add the possible, what patch can we add? We can add 2 to the patch to patch it up. So we add 2 to the nums, and then we do the same thing algorithm over where we have 1 alone. Now we have 2, we have 3. Now we have the possible combination of 3 and 1 and 3, 2 and 3, 1, 2, and 3. Well, we look at that. We have 1, 2, and 3, which are the possible sums, which is formed by some sum of elements in the array, which equal to 6. And therefore, we have the possible sums are 1, 2, 3, 4, 5, all the way to 6, which covers the range 1 to 6 as n stated. So the possible only patch needed is 1 where we're adding 2, right? Or the number of patches we add is 1, and that value would be 2. So that's kind of it's a complicated little rule we have there, but hopefully that explains it. And likewise we have here. So we want to basically have we have the nums array 1, 5, and 10, and we want to make this possible sum of 6 out of it. So how many numbers can we add to this in order to make that possible? So the numbers, well, the answer is given here, but we can patch 2, right? 2 and 4 add to here such that we have the sum of basically 10 plus 5, 15, plus 4, which is 15, 19. Then we have plus 2, right? Then plus 1. So basically, we need 2 numbers to make the combination where we'd add we could add to 20. Right? We could make the sum actually of 1 all the way to 20. And the possible sums of 1 all the way to 20. So it's for this one we need to add 0 numbers to make the patch equal to sum because we have 1 plus 2 plus 2 equals 5, which is our answer. So basically we have 1, yeah, that's 1. We have 1, we have number 2, 2 plus 1 equals 3, 2 plus 2 equals 4, then 2 plus 1 plus 5 equals plus 1, 2 plus 2 plus 1 equals 5. Yeah, I'll just describe that a little bit easier. So basically, for that array there, right, we take 1 alone, we take 2 alone, we take 1 plus 2, that gives you 3. Then we have 2 plus 2, which gives you 4. Then 1 plus 2 plus 2, which gives you 5, which is inclusive of 5 all the way to 1 to 5. Right, and that's kind of what we do about that. So how are we going to do this? So my first intuition is actually to use a greedy algorithm. So if we basically want to find the smallest number, which we don't have yet, right? So we sum them all together, and then we find all the numbers that we don't have yet. So how are we going to do that? So given the example, I'll run an example here. So nums equals to, let's say, 1, 2, 4, 13, and 43. So we want to basically make a sum such that we go from the smallest number, adding them one by one, and always keeping a possible range of numbers that we can get from the form of 1, 0, 0 all the way up to k, basically, right? Which is k is the number of n's, or n integer there. That is not a union of these intervals, but only one interval. So let's go to an example. So say, for example, we have one, we did not choose any numbers yet, so we have basically the interval going from 0 to 0. That's our first step. What are we missing next? We're missing 1, right? We have 1 here, so let's take the 1. So no, we do have a 1 yet? Nope. So we take the 1 we have in the interval and add it to our interval. So now we have 1 all the way to 0 all the way to 1. Great. Next, what are we missing? We're missing number 2. Do we have a 2? Yes, we do. So we take the number 2. We could take that alone. Then we can also add to, we take it and we add it to our largest number, which is 1 all the way to 3 now. Okay, next one, what do we need to make next? We have 1 here, 0, 1. We have 2. I'm just gonna 0 all the way to 2. Then 1 plus 2 equals 3. We have that. Next, what are we missing? We're missing 4. Can we make 4? No. So actually, we do have the number 4. Let's take that. Right? We're gonna take 4. 0 all the way to 4. So can we make 5? Yes, we can. Because 4 plus 1 equals 5. Can we make 6? Yes, we can. 4 plus 2 equals 6. And then can we make 7? Yes. 4 plus 2 plus 1 equals 7. So now our interval is all the way up to 7. Right? Next thing, what do we need? So can we make can we get 13, right? The answer is yes. We're missing it, right? We can't make 13 from any of the remaining results because what's the number going next? 8. How would you make 8? We can't make 8, right? Because once we sum all these together, we can't make 8, so we're missing something. We're missing the number 8. So we're going to add a patch, right? So add a patch 8. So now that we have the patch of 8, we can continue going on to, we can make everything between 1 all the way to 15 now, because we can't make 8, right? So now going next. Next missing number after this is 16. So there's a hidden rule in there that if we can't make the next number after it, we have to add a patch. So can we make 16? With 16 is more than what we have. So the next number of the array is 13, right? So we have to create another array. So we have to create a number which is 28, right? Well, not 28. We have to add 13. 13 is already added. So we add number 15. 15 plus 13 is included here already, which is going to bring up all the way to 28. Right? Because this is 15 we add as a patch, and 13 we have. So we could make any number between 13 plus 15, which is 28. So we can make a sum of any of the remaining numbers with 15 included. I'm going to add that there now. Under 28. So next missing number after 28 is 29. Can we make 29? 29 is less than 43, so we need to add 29 to this. So we add another patch, which is, I'm just gonna patch 15. So we add 29 to this. So 0, 29. So now we can make any numbers between 0 to 29, and that's going to basically call 29 as a patch. And then we have intervals, right? We have 29 plus, let's see, 29. So we add 29 as a patch. And then we can make it all the way up to 0 to 56, 7. And then that's pretty much our last number. And it's bigger, it's 59. 57 is bigger than our last number in the sorted array. So therefore we can cover everything from 0 all the way to k, if k is the number. And then that's pretty much the algorithm. Alright, so let's do the greedy algorithm. So we're gonna say jump, let's call it front. Your front number, just going to initialize to 0. We're going to have a output, which is going to store our maximum number of patches. I'm call it patches actually. Patches 0. Then we're going to name this to our reach, right? How far we can go. And greedy algorithm, that is. We have our index, which is going to initialize to 0. So while our reach is less than n, we are going to find if the index is less than the length of nums, and nums at index is less than or equal to our reach plus 1, we are going to increment reach by the number of index at the index. And then we also have to increment our index counter by 1. If this is not the case, else what we're going to do is basically we have to add a patch. We're going to increment our patch by 1. And we're going to find out which number is. The number is going to actually be, the reach is going to be 2 times our previous reach number plus 1. And we got to return all this after once we're done our patches. So let's just submit it to see how that works. So knowing this, I mean, this part's pretty much straightforward, but this part right here, reach is 2 times the reach of the old reach plus 1. That's a mathematical type of approach to it. That's what makes it so hard, because how do we know what the next patch is going to be, right? Using the greedy algorithm. But yeah. So the time complexity of this is a while loop. So we have to reiterate through each time n. So it would be big O of n for the time complexity. Space complexity is constant space because we just insert it as an integer variable. So we have constant space complexity. All right, that's it, guys. Have a great day.